In one way or the other, power must be transferred from one source of energy to another in a mechanical device. The most common and cheapest form is to use a belt and pulley. This power is either gotten from an electrical or mechanical generator to transfer a rotational motion to the application. Hi, I am John Rohe Carretero. Me and my group mates are going to discuss on belts and pulleys. Talking about power transmission, a belt is the cheapest form. It is a loop of flexible material used to link two or more rotating shafts mechanically, often in a parallel form. These belts may be used as a source of motion as it transmits power more efficiently. Pulley is a wheel that carries a flexible material in the form of a rope, cord, cable, chain, or most commonly belt. Is always mounted on a rotary part of the energy source so that power can be transferred through the belt to the device, thus serving as a source of power to that device. Pulleys are used singly or in combination to transmit energy and motion. Belts and pulleys are purposely designed on any application that requires a rotational motion from another source. There are many applications of belts and pulleys. They are used in automotive engines such as cars, trucks, buses, stationary power generators, marine engines, aviation engines, and etc. But where can belts and pulleys assembly be found in industry? They are commonly found in industries that require rotational motion from another source, in cranes, bulldozers, escalators, elevators, extended ladders, conveyor belts in factories, and many more. Classifications of belts. All power transmission belts are either friction drive or positive drive. Friction drive belts rely on the friction between the belt and pulley to transmit power. It requires tension to maintain the right amount of friction. Positive drive or synchronous belts rely on the engagement of teeth on the belt with grooves on the pulley. 1. Flat belt, used where low power and more speed is required. Rectangular cross-section types and the shaft distance must be between 5 to 10 meters. These belts transmit power by using friction produced between the belt and pulley. Finally, the pulley's rotation in flat belts is in the same direction and the efficiency of the belt is around 98%. However, the belt makes little noise. 2. V-belt, used where shaft distance is less than 2 meters. They offer moderate speed and high power. Unlike flat belts, V-belts are in trapezoidal cross-section. Multiple drives are possible in these types of belts. In V-belts, there are several types. A. Classical V-belts. Classical V-belts are frequently used individually, particularly in A and B sizes. The larger C, D, and E sizes generally are not used in single belt drives because of cost penalties and inefficiencies. Multiple A or B belts are economical alternatives to using single belt C, D, or E sections. B. Narrow V belts. They offer higher power ratings than conventional V belts. They have a greater depth to width ratio, placing more of the sheave under the reinforcing cord. These belts are suited for severe duty applications, including shock and high starting loads. C. Banded V-belts. They solve problems conventional multiple V-belt drives have with pulsating loads. The intermittent forces can induce a whipping action in multiple belt systems, sometimes causing belts to turn over. The joint configuration avoids the need to order multiple belts as matched sets. 3. Circular belt, used where the shaft distance is more than 5 meters. It's a circular cross-section and it is used to transmit high power. Circular types of belts are used on applications that require smaller initial tension and vibration, and noise will not be produced. 4. Timing or synchronous belt are popular types of belts that serve alternative purposes. They are mainly used in internal combustion engines to transmit power. They are known as positive drives as they are more reliable and precise.
The next topic is the function of each type of pulley. The first type of pulley is solid pulley. Solid pulley is made from a single piece of cast iron. Solid pulley are relatively small in size. This pulley can be mounted on shaft by inserting from one end. The second type of pulley is the split pulley. It is split in halves and can be joined by the rim and the hub means by the bolts or links. This pulley can be mounted on shaft at any place without changing the assembly of bearing and shaft. The third type is tip or cone pulley. A tip or cone pulley is used when the speed of driven shaft is to be changed very frequently, as in case of machine tools such as lathe, drilling machine, and etc. A tip pulley is an integral casting having 3 or more number of pulleys of different diameter. Each tip pulley is mounted by driving, and driven shaft can be varied by shifting the diameters of driving and driven pulley shaft, as the same belt will operate when shifted on different pairs of pulley. The fourth type is the fast and loose pulley. When a number of machines are operated from a single power source, each machine is provided with a fast and loose pulley arrangement. With this arrangement, any machine can be started or stopped at will. While the lathe shaft is running continuously, the fast pulley is mounted on the shaft with a cage joint, whereas the loose pulley runs freely on the shaft. The diameter of the loose pulley is slightly less than the fast pulley, so that when the belt is shifted on the loose pulley, its tension is reduced. Power is transmitted only when the belt is on the fast pulley. Loose pulley takes care of the idling time of the machine and does not transmit any power. Next type is the jockey pulley. It is an idler pulley and is used to increase the angle of contact in an open belt drive. It is mounted near the smaller pulley of the two pulleys and is placed on the slack side of the belt. The increase of the angle of the contact will lead to increased power transmission capacity of the drive. The next type is the guide pulley. Guide pulley are used to guide the belts when connecting non-parallel intersecting and non-intersecting shafts. The guide pulleys guide the belt to keep the belt in a proper place. And last but not the least, the groove pulley. Groove pulley have V-grooves or circular grooves on the rim to carry V-belts or ropes. It is generally made from cast iron. The groove pulley on the rim helps to increase the frictional grip of the V-belts and ropes on the pulley. Therefore, the chance of slipping is reduced. Next topic is the specific application of each type of pulley. First is the solid pulleys. Solid pulleys are mostly used in oil expeller and also in the engineering industries. This pulley is lower in cost, so it is affordable to every industry. Next, the split pulley. Split pulley are used with an electric clutch brake in some applications like high-speed mower applications, to stop the rotation faster with less wear on the clutch rotor and armature. Next type is the step or cone pulleys. Many machines use step or cone pulleys to enable the same driver motor to produce different output speeds, such as in drilling machine. The next type is the fast and loose pulley. Fast and loose pulley used on shaft enables machine to be started or stopped at will. A fast pulley is keyed to the machine shaft while the loose pulley runs freely. The belt runs over the fast pulley to transmit power by the machine, and it is shifted to the loose pulley when the machine is not required to transmit power. By this way, stopping of one of the machine does not interfere with other machines which run by the same line shaft. Next is the jockey pulley. Jockey pulleys are used in the steering section of the system. Jockey pulley is like an idle pulley, which is used for increasing the angle of contact in an open belt drive. Hence, increasing the angle of contact steer to the increased power transmission capacity of the drive. Next is the guide pulley. The guide pulley is a common part that's found on the majority of the vehicles on the road. Its primary function is to provide the tension and guide the engine drive belt. This belt wraps around the various parts of engine such as power steering pump, alternator, water pump, and others. And last but not the least, the groove pulleys. Groove pulleys are solely used for transmitting power between two parallel axles. The next topic is the parts of pulley. First part is the rim. It is the periphery of the pulley on which the belt runs. The outer face of the rim is made from slightly convex, which is called crowning. This kept belts at center when pulley is misaligned. The next part of pulley is the hub or boss. It is the central hollow cylindrical portion of pulley. The size of bore on hub corresponds to the diameter of the shaft. The hub is mounted on the shaft and its key weight is provided to fasten the pulley to the shaft with the help of a key. Next part is the arms or rib. It is a joining member of the hub and the rib of the pulley. It may be straight or curved. Its cross-section may be circular or elliptical. Pulleys with smaller diameter are provided with a rib which is like the circular disc joining the hub and rim. The next part is the shaft. Shaft is designed to support movement and change of direction of the taut cable or belt. It is also used to transfer power between the shaft and cable or belt. The next is the screws. It modifies force and motions that are known as power screws. A screw jack converts torque to thrust. The thrust is created by turning the screw in a stationary nut. And last is the bush. Bush are a locking mechanism used for fixing pulleys, sprockets, and couplings to drive shafts. They are typically used in power transmission drives. Bushes are made from precision cast iron and are computerized ease for size identification.
Alright, so here's our condenser fan belt because we are in our condensing unit. There are two compressors. Here's our condenser coil. So what we're going to do is simply take our hand here, and as we push up, we're actually going to pull towards us. And that's it. Belt is removed. Here's our new belt. This is an AP70. So we're gonna start at our pulley and we're just gonna go around, as you can see, just like that. We are in. Next, we're gonna go to our flywheel. We're gonna take our hand like this, set it up, and we're just gonna spin it. And that's it. New belt installed.
So let us now move on to the basic parts of belt and pulleys. So the basic parts of a belt or a belt drive. First is the tooth belt. A tooth belt, timing belt, cog belt, or synchronous belt is a flexible belt with teeth molded onto its inner surface. It is sometimes designed to run over matching tooth pulleys or sprockets. Tooth belts are used in a wide array of mechanical devices where high power transmission is desired. So next is the belt tensioner. A tensioner is a device that applies a force to create or maintain tension. The force may be applied parallel to, as is in a case of a hydraulic bolt tensioner, or perpendicular to, as in the case of a spring-loaded bicycle chain tensioner. And the next is the tensioning pulley. A pulley over which a belt is caused to pass in order to keep it taut. Next is the deflection roller. A secondary roller mounted for rotation about a deflectable shaft. Pressure applying means coupled to the ends of deflectable shaft or moving the second roller into contact with the first roller. The second roller, including an outer shell mounted for rotation relative to the deflectable shaft. Next is the crankshaft. A combustion of the fuel-air mixture in the engine produces power. This power transformed into a rotary movement of the crankshaft. The crankshaft has to withstand the considerable loads in the process. On one hand, it is subjected to severe bending and torsional stress. So let us now move on to the basic parts of a pulley. First is the sheave or pulley wheel. A sheave or pulley wheel is a grooved wheel often used for holding a belt, wire rope, or rope and incorporated into a pulley. The sheave spins on an axle or bearing inside the frame of the pulley. This allows the wire or the rope to move freely, minimizing friction and wear on cable. Second is the shaft or axle. The drive shaft acts as a medium for transferring the power generated, enabling them to turn. This in turn puts the pulley in motion and puts the pulley in motion. The force that is transmitted by the drive shaft is referred as torque. Third is the rope. So a length of strong cord made by twisting together strands of natural fibers such as hemp or artificial fibers such as polypropylene. So let us now move on to the formulas. The formula of center distance between pulleys. So the formula is 4 times belt length minus 6.28 or 2 pi times the diameter of the first pulley plus the diameter of the second pulley plus the square root of 4 times belt length minus 6.28 times the diameter of the first pulley plus the diameter of the second pulley squared minus 32 times the diameter of the first pulley minus the diameter of the second pulley squared, and all divided by 16. So let us move on to the next formula. Let us move on to the sample problem. Find the center distance between pulleys. So the given is the diameter of the pulley, the diameter of the first pulley and the second pulley, and the belt length. So we will have to use the formula that I have introduced. So this is the 4 times belt length minus 6.28 times the diameter of the first pulley plus the diameter of the second pulley plus the square root of 4 times belt length minus 6.28 times the diameter of the first pulley plus the diameter of the second pulley squared minus 32 times the diameter of the first pulley minus the diameter of the second pulley squared, all over 16. So you just have to input the given numbers or the given information in the formula, and if you calculate it with a calculator, you will come up to an answer of the 600 millimeters or the center distance. That's the value of the center distance. The next formula is the diameter and speed ratio. So in the illustration, there are two circumference, two pulleys that is held together by a belt. So to calculate the velocity ratio is diameter of the driven pulley divided by the diameter of the driver pulley. So the driven pulley is 400 millimeters while the driver pulley is 200 millimeters. So 400 divided by 2 is 400 divided by 200 is 2, or 2:1. The smaller driver pulley turns also 2 times, so it conclude that the smaller driver pulley turns 2 times to make the driven pulley turn once, or the bigger pulley turn once. The output speed of the larger pulley can be calculated using the information available. The input is 20 revolutions per minute, and the velocity ratio has been calculated as 2. So the formula for the output speed is input speed divided by velocity ratio. So it is equivalent to 20 divided by 2, which answers 10 revolutions per minute. So that is the output speed of your driven pulley. So the next formula is the length of belt. So the formula is pi times the first pulley, or the diameter of the first pulley, plus the diameter of the second pulley, times 0.5 plus 2 times the center distance plus the pulley of the second pulley minus the first pulley squared divided by 4 times the center distance. So here are the sample problems. So find the belt length. So the given values are the center distance and the diameters of the pulley. So you just need to input the values in the formula that was introduced, and you will come up to this answer, 1675 millimeters. So next, the next formula is the system of masses in pulleys. So it is just a basic formula that shows the acceleration of a system with masses in pulleys. So it is just the acceleration of a system, and its absolute value is equal to the summation of force divided by the total mass. So you just have to input the summation of the force, which is the mass times gravity, and divided by the total mass, which is 8 kilograms, and you will have the acceleration of 2.45 meters per second squared. And that would be all. Thank you for listening.